Alright, in this video we're going to talk about divergent and transform plate boundaries. This is a divergent plate boundary, and as you can see we have two pieces of oceanic crust. The convection currents are drawn in for you, and they show the direction that the plates are going to be moving on top of the asthenosphere. So, this piece is going to be moving to the right because that's the way the convection currents are pointing, and this piece over here is going to move to the left because that's the way the convection currents underneath that piece of crust are moving. So you can see there's a gap that's created by this separation. They're dividing, they're separating, they're pulling apart, and that gives an opportunity for the inside of the Earth to come out. So we see the plastic asthenosphere come up and fill this gap all the way to the top. So it hits the cold ocean water, cools and hardens into rock. This is where our youngest ocean floor is going to be, right here, nearest the plate boundary and the center of that plate boundary. The oldest ocean floor is going to be furthest away from the plate boundary, so the age increases as you move from the center of the plate boundary out to the edges, left or right. You could say that a divergent plate boundary makes a mountain range on the bottom of the ocean, and the name of the entire feature is a mid-ocean ridge. That's what this whole thing would be called. So this whole chain of underwater mountains would be the mid-ocean ridge. The depression, or the low part in the middle, is called a rift valley, and that's referring to this low-lying spot right here where the youngest ocean floor would be, the depression or the dip on that actual plate boundary. An example of where you can see a divergent plate boundary is the Mid-Atlantic Ridge, which runs smack dab down the center of the Atlantic Ocean from the Arctic Circle all the way to the Antarctic Circle. In the picture to the left with the scuba diver, that's somebody that's actually sitting in the Rift Valley in the Mid-Atlantic Ridge. And the thing that I think is kind of cool is that you could actually touch the rock on the right, and that is attached to the continent of Europe. And the rock to the left is attached to the continent of North America. So it's separated right down the center right here. That's the crack where the plate boundary is actually located at. This is the last type of plate boundary that we have to talk about, and it's called a transform plate boundary. Transform plate boundaries, for the most part, happen between two pieces of continental crust. So you can see some of the features that form here. We have some mountains that have built up over the course of time, but the direction that these plates are moving on a transform plate boundary is they are sliding past each other. So I'm going to draw an arrow up, and then my other arrow is going to be down. Okay, so they're sliding past each other in opposite directions. Mountains form over the course of time as the rocks are sliding past each other. Maybe for a period of time they get stuck, and nothing happens for a year, 2 years, 5 years, even 10. But over the course of time, that force and that pressure builds up, and then all of a sudden one day they snap into place, and all of that energy is going to be released in the form of an earthquake. So I'm going to draw in my earthquake here. So on plate boundaries, we are on a transform plate boundary. We get mountains and earthquakes. Example of where you can find transform plate boundary happening is in California in the United States, and half of the state of California is attached to the North American plate, and it is sliding down this direction. So that has the city of San Francisco on it. The other half of California is attached to the Pacific plate, which is moving the opposite direction this way. So in a couple million years, the city of San Francisco is going to be located right next to the city of Los Angeles. So if you live in San Francisco and you're looking out your kitchen window, you're going to see the skyline of LA. And this is just an aerial view in the picture to the right of the San Andreas Fault, which is the name of the fault that runs right through the state of California and between LA and San Francisco.